In this video, I wanted to talk a little bit about a math trick that's been around for a while for solving quadratic equations. Now, it does work, but most of the videos that I've seen just demonstrate the trick or the method, don't really explain it. So first I want to just show you the traditional approach. So we see the following quadratic equations. And the traditional approach is to just factor. One side is 0. You factor the quadratic, set each factor to 0. So this factors, the left side factors into 7x plus 2, x minus 3. You set each factor equal to 0. X minus 3 equals 0 when x is equal to 3. 7x plus 2 equal to 0. Bring the 2 over, becomes negative, divide by 7, you get negative 2 over 7. And the method used, that is the shortcut method, is they do this. So they tell you multiply the coefficient of the lead term, that's x squared, by the constant term over here, minus x, and you get minus 42. And then they ask you to find factors of negative 42 that add up to negative 19. And that's negative 21 and a positive 2. 2 times negative 21 is a negative 42, and negative 21 and 2 is negative 19. And then they tell you to divide this by the lead coefficient, which is 7. Reduce and change the sign. So 7 into negative 21 would go negative 3, change the sign. This will give you 3. 2/7 is already in lowest terms, change the sign, and that becomes negative 2 over 7. And of course, that's the same answer we got. That's the shortcut. Now, what's actually happening here, let me clear this, is you're finding solutions to this equation. So let me rewrite this equation as x squared minus 19x. And then they're replacing this third term by the product of 7 and negative 6. Which of course is negative 42. And you get to something like this where the coefficient of this equation is 1 instead of 7. And of course the basic idea between these kind is that these are easier to solve than the ones that have a coefficient that is not a 1, because all you got to do is find factors of negative 42 that add up to the middle term. And we got the negative 21 and the 2. So we could factor this out. X minus 21 and x plus 2. And now we have this factored out, set each factor equal to 0, so x minus 21 equals to 0 when x is 21, and x plus 2 is equal to 0 when x is negative 2. Now, these are the solutions, obviously, these are the solutions to this equation, x squared minus 19x minus 42, not this one, that's a different equation. Then again, what we did earlier, if you divide each of these by 7, divide this by 7, and this by 7, then of course you get the answers to the other equation. This would give me 3 and negative 2 over 7. So you get the answer to the original equation indirectly by rewriting it and doing this situation here, dividing by 7, the lead coefficient. So here I'm just basically just showing you what the trick is. Then we'll look into why it works. You kind of get an idea as to what's happening here with it, but let's clear this one. And we go to the next one. And this one we have 15x squared plus 17x plus 14 is equal to 0. So again, if you're going to do it a traditional way, you would just factor one side is 0. You play around with the coefficients or the factors of the lead term 15 and 4 and get values that when you multiply it back, it gives you especially the middle term. So you can check it here using your 4 method. 3 times 5x is 15x squared. 4 times 1 is 4. And 5x and 12x is 17x. And then we set each factor equal to 0. Solve. 3x plus 1 equals 0. Take the 1 over, divide by 3, you get negative 1/3. 5x plus 4 equals 0. Take the 4 over, negative 4, divide by 5, and you get the solution to this equation. Now, if you use the shortcut, on the first one I went ahead and wrote out the equation that you used to get those values, but the shortcut method is, again, just simply take 15 times 4 and you get 60. And then you want factors of 60 that add up to the middle term. So again, the equation they're actually solving is x squared plus 17x. And for the third term, they replace it by 4 times 15, which is 60. So you want factors of 60 that add up to 17. So that would be 5 and 12. And then they ask you to divide this by the lead coefficient 15 and change the sign. And that will give you the solution to the original equation. 5 and 12 is actually the solution to this equation here. But it turns out when you divide by 15, You divide each of those by 15 and then reduce it to the 5/15, reduces to 1/3. And then you change the sign. That, of course, you saw why that was done in the example 1, why I actually wrote out the equation. And then this one reduces to 4 divided by 3, 4/5, and you change the sign. That's actually the shortcut. They don't actually mess with the equation, but I wanted to go ahead and give you the equation they're using just to give you a little bit of idea as to what's going on. So this is a shortcut. You just play around with the coefficients of this and getting the answer to the original equation. Now, why it works, we can set it up this way. Do this. And suppose we have ax squared plus bx plus c equal to 0. Ax squared plus bx plus c is equal to 0. That's your standard quadratic equation. So in the first one, it was 7x squared minus 19x minus 6. So the a was a 7, the b was a negative 19, and the c was a negative 6. So here's what's happening. I'm going to call this one, this is the main equation. This is one you would be given. And then, like I said, to derive that shortcut, they're actually rewriting the equation, leaving out the a, got x squared. The middle term stays the same. And then they use for the third term the product of a and c. And they play around with that. So here's what would how we'll do it to justify this. So what they're doing, like I said, is they're getting a solution to this equation right here. So I'm going to say this. We're going to say let R be a solution to equation 2. Okay, so you have to understand what a solution is. That means if I replace the x by r, this is going to be 0. So that means that, just like over here, the last one we got negative 1/3 and minus 4/5. If I were to plug those into the modified equation, I would get 0. So that would tell me then that replace the the x by r, this becomes my r squared plus br plus ac equals to 0. That I know for a fact. If r is a solution, this has to be true. What I have to do then, what the shortcut says, well, if you take the solution of this equation and divide it by r, it has to make this equation, it has to satisfy this equation. So that means then, if I take this equation, replace it by the solution that I got over here divided by a. So that means I replace the x by r over a. And then square it. That's how you check to see if something is a solution. You replace the x by that number, and if you get the value on the other side of the equation, which in this case is 0, then yes, it is a solution. So this is plus b, and this r over a plus c. So this gives me then, this is going to give me r squared, and then this would be a squared, but then I have an a, so that would cancel one of the a's, so this would give me this. This would give me br over a plus c. And then I'm going to multiply this by a and divide by a, only because I don't have an equation yet, so I just can't multiply both sides by a, because I want to show that it's equal to 0. So I'm going to multiply by a, at the same time divide by a. So if I multiply this by a inside, then this will give me r squared plus br plus ac. And then I want to show that this is 0. So notice this is the same thing, okay? Because I multiplied by a and divided by a, so I'm multiplying this result here by 1. Doesn't change it. So I multiply through by 1 over a, still get the same thing back. Okay, 1 over a times this is this, 1 over a times this is this, 1 over a times this is this. So is this equal to 0? Well, because of this right here, r is a solution to this equation, equation 2, and that's equal to 0, so this is actually 0. For a quadratic, a cannot be 0. So 1 over a is just a number. 1 over a times 0 is equal to 0. So this does equal to 0. And that's why the shortcut works. Mathematically, this shows why it works. I hope it makes sense. Thanks for watching. We'll see you next time.